Now, in our next application problem, we're told we have this wild roller coaster ride that has a section that's shaped like this function. I see an x squared there, so I know it's parabolic. It's shaped like a parabola. Where g of x is my vertical distance in yards, so in other words, how high it is. The roller track is from the ground, and x is a horizontal distance from the start of the ride. I want to describe the transformation of the parent function f of x equals x squared. Well, I think since I'm doing a parabola, I want to complete the square here. I want to put this in vertex form so it's a lot easier to see. Remember, when you complete the square, my coefficient of my x squared has to be 1. Well, right now it's negative 1 over 30, so I'm going to factor that negative 1 over 30 out of my first two terms. So I'm going to say negative 1 over 30 times, and I'll go x squared. Now, what do I multiply negative 1 over 30 by to get positive 10? Well, first off, it's got to be a negative, right? And then to get 10 over 3, actually. Well, to get rid of my 30, I'd multiply by 10 because 10 goes into 30 3 times. I multiply by 10 again to get my 10. So I'll get 100. So I'm going to say minus 100x. And then I'll subtract 100 over 3. Kind of an ugly problem here. Now I'll complete my square. Half of 100 is 50. I square the 50, I get 2,500. But actually what I'm doing is I'm adding a negative 2,500 over 30 to get that. So what I'm going to do is I'm going to go over here. I'm going to say plus 2,500 over 3. 30 over 30. Because my 30 there. Now, let's complete my square. So I'm going to get negative 1 over 30 times x minus 50 squared. And then I need a common denominator, so I'm going to take 1,000 plus 2,500. So that'll be 3,500 over 3. 30 days. So minus 1,000. Let me write it out here. I'm going to get a common denominator of 30. Okay, so I have to multiply by 10, so I get 1,000 plus, and then I don't need to change the second one. That's 2,500 over 30. So I get negative 1 over 30 times x minus 50 squared. Negative 1,000 plus 2,500 is 1,500. Well, 1,500 divided by 30, that'll be 50, won't it? So what transformations are going on here? Well, I am going to do a reflection over the x-axis. So it's going to be a sad parabola. I'm going to do a vertical compression by a factor of 30. And then I'm going to move my graph 50 units to the right, because it's x minus 50, and 50 units up. That's what's going on in our graph here. Now let's take a look at example 7. Now I want to suppose the ride designed is to increase the highest point of the ride to 70 yards. In other words, I want the highest to be 70. So instead of being up 50 yards from the ground, it's to be up 70 yards from the ground. So rewrite g of x to this change. I want to graph both the functions on the same coordinate axis using a graphing calculator. So I'm going to say g of x then. The only thing I'm going to do is I'm going to change my 50 to a 70. So I'll say negative 1 over 30 times x minus 50 squared plus 70. Now you can graph both of these on the same coordinate grid. I don't care if you do the original function or or a transform function because these are the same. And then we'll do our, when we change it to 70. So let's go into Desmos, and I'm going to make a new, whoops, I'm going to make a new graph. There we go. It's being kind of slow here for me today. And so I think I'm going to write in my transform function. So I'm going to say f of x, my vertex form, that's what I meant. I'm going to say my vertex form, so f of x equals, I'll say -1 over 30 times, and I'll go parentheses, I'll go x minus 50 squared, and then we'll go plus 50. And so I want to be able to see my graph, so I'm going to adjust my windows so I can see my graph. Now I'll do my transform function. I want to be able to see up to 70, so I'm going to adjust my graph there. So I'm going to say g of x equals, I'll say -1 over 30. And then parentheses, whoops, get out of there. There we go, parentheses, x minus 50 squared plus 70. And there's our graph. Now, just to show you, if we go back to our original problem, I want to show you that my first graph is the same no matter what. So I'm going to say h of x. I'm going to write my original function here just so you can see it's the same, because I think it's kind of neat to see that. So h of x equals, I'm going to say -x squared over 30 okay, plus 10x over 3 and then minus 100 over 3 up. And notice my green and my red are the same. If I shut off my green, you can see it goes straight over that one. So these two are the same. I don't know why, when I shut it off, why it wouldn't go back. There we have it. Keep on going to the wrong one. Okay, now we have it.